I'm Professor Lucy Rogers, the inventor with a sense of fun, and I've made it my mission to travel the UK to find out how everyday tech can give people and places the engineering edge. It's Bank Holiday Sunday, early in the morning. I have got the roads to myself. Lovely cool at the moment, but the guy in the garage has just told me that it's going to be over 30 today. It's going to be a scorcher. It's lovely having these open roads all to myself, especially as I don't really know where I'm going and I'm often in the wrong lane.
Now turn off to the left.
I'm heading to an airfield near Grantham for the UK Drone Racing Open. I'm going to see some of the best drone pilots from around Europe compete to be crowned the champion of Britain. These machines aren't just any drone you can get on the high street. These are specialist racing drones designed mainly by the pilots so that they can cut the corners, do the things that they need to do, get in and out, a bit more like dog agility than a straight Grand Prix. I've seen some videos of the pilots and they're wearing goggles, so they've got a first-person view of actually where their drone is on the circuit. Not only do these pilots spend hours and hours training and practicing flying these drones, but they also spend hundreds of hours actually making their drones and custom building their drones to be exactly how they want them. I've never built a drone before, so if I got asked, well, it'd have to be straight onto Google. I had to look at one of the shops and there's thousands of components you can get. So how do they know what to do and which bits are going to work best? I know you need motors and I know you need rotors, and there must be some kind of control system in there to be able to see what you're doing and talk to the remote control system. But I really don't know what else is involved. I first tried to fly a drone about 10 years ago, and it was my neighbours, and I went round their living room, and it was a small little drone, and I was trying to fly it around and really wasn't very good at it, and ended up with my neighbour's houseplants actually being in tatters, of which she wasn't that impressed. Sorry, Fiona. I've been told that I'm not actually allowed to have a go on one of these drones because they're so difficult to fly. So my big question is, how can drone pilots use everyday tech to give themselves an engineering edge? Look at them. I've just parked up and I hadn't realised that it was going to be just this amazing festival of flying things here. There are thousands and thousands of people. There are rows of caravans. It's been a weekend event. I can see biplanes footing around, doing loop-the-loop. There's some jets that have really scary noises. They're 8 foot long, these things. I saw one take off and it was really like I was on a military base. But I'm actually here for the drones, which I think are going to be much more exciting. Today I'm hoping that I'll get a chance to speak with the UK Racing League champion, Brett Collis. He's one of the best pilots in the world and can hopefully tell me what it takes to be a drone racing champion and what everyday tech he's using to give himself an edge. I've been too busy keeping my head up in the clouds watching these jets, but I've just looked around and I can see a whole load of white inflatable tubes and hoops and things. This must be where the drone obstacle course is. Oh, and can you hear that? That's not the foot of a biplane anymore, or the the beautiful dragonfly, that's a swarm of angry mosquitoes flying about. That's the drones going around the course. So the course itself is about half the size of a football pitch, and it just looks like a really weird croquet game. There's hoops and barriers and flags around, and there's spots on the ground, because this is a whole 3D race. These drones are going in, out, round, up, over, back. I can't even work out what the course is. These things are going so fast. I've seen where all the pilots go. They're heading back, or they come from this huge white marquee. And looking from a distance here, I can see big screens. I can see people in there. There looks like there's an awful lot of tech going on in there. Come on, let's go and find out what that is. So now I've just come into the big marquee, and it's like coming into an Aladdin's cave. There are tables and tables around the edge, all with toolkits, soldering irons, and drones. And if I'm coming up to one of these drones, you can see that the rotors on the top are quite the obvious thing. So there's 4 on this one, and it's got a 3D printed case on it. And in front of that, you can see the camera. There must be some antenna on there, the batteries, a couple of electronic control boards. One must be the motor controller. There'll be something that sends the camera signal back to the goggles, and something that's taking the information from the radio control transmitter to actually receive on here and tell the drone what to be doing. And it's really quite light. It's I don't know, a little bit heavier than a mug of tea, I expect. And it's about the size of, well, I can easily hold it in one hand. It's actually a lot smaller than I expect. It would sit on a piece of A4 paper quite happily. So it's not as big as I was expecting and lighter than I was expecting, but it's compact. I mean, it's a solid little thing. But the frame is made of carbon fibre. So obviously weight is really important on these things. There's just lots of things that I'd see everywhere. You know, you can see motors, I can see cameras, I can see the connector. That must be the antenna that I've just found. It's basically a bit of wire sticking out the back, but that must be the antenna for the camera or the receiver for the from the transmitter. So, but looking around this whole place, you can see, everyone's got their soldering irons, pliers. Pliers seem to be in very high demand around here, so there's an awful lot. So I expect things get bent, and lots of spares and screwdrivers and stuff. I can see here that you can see who the individual teams are or the individual groups, but they're all chatting to each other. Everyone's really friendly. And you can see people are asking advice and asking, oh, what have you got there? How have you done that? Camaraderie here is really good. Something I probably wasn't expecting in competition for a world-class competition format. Three sides of this room are full of tables, but over in the corner, and this is amazing. I can see that there's a couple of chaps sitting in front of some big TV screens, and another TV screen where all the pilots' video is being live streamed, so we can actually stand here and watch what each of the pilot is seeing. But the guys in the corner are actually live commentating this, and it's being live streamed. And someone said earlier that if there's a conflict or someone says, no, you didn't go through that gate, they're crowdsourcing the referees, because it's actually a virtual spectator sport. People are watching it around the world and getting the commentary and seeing all 6 at once. It's really fascinating, and this is just tech that's available to me. It's hobbyist style tech. Okay, it's high end, but it's still hobbyist cost. I've been really impressed with what I've seen in here. I really wasn't expecting this amount of technology. And I can't actually see how it all goes together. And I mean, I knew the pilot skill was going to be really important, but it seems this technology, people are putting a lot of effort into this. This is a bigger thing than I thought it was. I need to speak to Brett about this.
What? You're not supposed to tell anyone, Luke.
That's all right. We're only recording, and we'll put it on all live soon. Brett, I just saw you flying out there. Have you been having a good day?
Yeah, really good day. Weather's amazing for a bank holiday weekend here.
Isn't it? Yeah. Can you fly in the rain?
We can for a bit. Some people sometimes kind of waterproof their quads with kind of electrical tape and things like that. But if any of the water makes it either onto the camera lens, which makes it hard to fly, or kind of on the electronics itself, it's normally game over. It kind of falls out of the air, or you just can't see where you're going.
Yeah. So how hard is it to fly these things?
It's pretty hard to fly at the level we're flying at. I guess kind of it's not too bad. They're quite a bit different compared to the aerial photography drones, where they're kind of very GPS stabilized, something like that.
Right.
These, if you're heading towards a gate, it doesn't avoid it for you. You go straight into that gate and kind of explode.
So have you got GPS on these?
No, so these are basically just using gyros, and they do have accelerometers, but we're basically just using the gyros to kind of stabilize it. But when
so that keeps it in one plane.
Yeah, that kind of keeps it on like the same trajectory.
Okay,
and then if we just kind of command it to go into a different one. But yeah, other than that, that's all we use. And just
so what, the rotors tilt? Is that how you turn it?
No, so basically you kind of got 4 rotors, and then they independently control their speed by kind of speeding up and slowing down to kind of adjust the attitude of the quad and kind of.
Oh, right, so there's no tilting involved.
Yeah, there's no
tilting
as well.
It's just all on speed.
Yeah, it's just all on the speed of the things, and they change really fast, kind of the motors.
Yeah.
So the technology into that is quite impressive.
So I've heard that you spend hours actually building your own drones. Could you fly someone else's?
Yeah, so we can fly each other's. We're generally not as fast on each other's. I mean, some people it's all very much kind of personal preference, and people have different kind of rates, so how fast the drone reacts to your stick inputs.
Oh, right,
and also kind of how you want it to fly. So some people want it to fly kind of more robot-y, and kind of in terms of it will lock in on a course. Other people want it to be kind of smoother and more kind of transitional to their stick inputs.
So how long have you been playing? I'm sorry, that's belittling.
Fine. No, they are toys.
How long have you been flying drones?
So I've been flying these since I think 2015.
Right.
So early 2015, but I flew kind of radio controlled models, helicopters, stuff like that since I was like 8 years old. So like almost 20 years, I think.
So you and a joystick sort of combined.
Yeah. PlayStation generation, things like that. So it kind of helps. Like the controls are very similar to kind of what you get on an Xbox or a PlayStation. And
I've been looking around, and it is quite a young person's sport.
Yeah. So I think kind of probably the top 4 or 5 people here are probably all under the age of kind of 30 as a maximum or something like that. I think. So yeah, it's kind of having fast reactions definitely helps.
And you're actually looking as if, so you've got goggles on and you're looking as if you're actually on the drone.
Yeah, so you have an analog camera on the front that kind of transmits over a 5.8 gigahertz link down to the goggles, and then we receive that and kind of fly it as if we're in it, apart from when we crash.
And that's quick enough?
Yeah, so I think the round trip latency is kind of around 30 to 40 milliseconds maximum.
Right.
So yeah, quite low latency. Yeah, that's how we fly them.
Do you get seasick?
The first few flights can be a bit weird, and I don't really like flying standing up because you kind of start to move with the drone and you kind of feel slightly detached, but you kind of get used to it after a while. You kind of learn to detach yourself, and like at first when you crash you like wince, but then after a while you just kind of go, you've got to repair it now instead.
You stop wincing.
Yeah.
So I understand there's a lot of skill involved in actually flying these, but is it just down to personal skill, or can you make a difference on your drone putting technology in it?
So I think it's probably kind of 80% skill and then kind of 20% in building them. So a really fast pilot will fly a bad drone really fast regardless, maybe not quite as fast as a normal one, but a lot of thought goes into kind of how you design it, the propellers that you use, the motors that you use, all of the electronics in here are quite complex.
Right.
And in terms of how you tune those and kind of set them up is very much personal preference and depends on the pilot.
So are most bits like pre-done just for drones, or do you buy individual bits and put them on yourself?
So most of the stuff now in drone racing is kind of specifically built for drones. There is kind of some generic components like the microcontrollers and things that are used on the flight controllers. They're kind of generic across loads of different things. The things that we use for the RC link can be used in kind of other industries as well for communication methods.
Right.
So there is some
So
kind
the sort of things that they'd use on Robot Wars.
Yeah, stuff like that.
Yeah.
Kind of the control systems could be exactly the same. People play kind of Spectrum, Futaba, things like that.
Yeah.
But yeah, they are kind of tailored a bit towards the drone racing industry in terms of how they react and how they're built to work. And the form factor as well is quite important because we want to build them as light as possible.
Right. So how heavy is that? You've got a drone in your hand there.
I think it's about 310 grams without the battery.
Oh, right.
So about kind of 530-ish, kind of all up weight, kind of flying. And we get about kind of a minute and a half, 2 minutes of flight time out of that.
That all?
Yeah.
Wow. Wow, that's yeah. So what voltage are you running them at?
So currently I'm on 6 S voltage, which means kind of 6, I guess, kind of cell phone batteries in series to make up about kind of 25 volts is what we're at now.
Yeah.
25 volts DC.
Doesn't that cause you problems?
Sometimes you can have problems with kind of stuff catching on fire. There's a few things that we've changed to hopefully prevent that. Some people still have it happen, but it depends on kind of how you build them. And it's kind of definitely more of a challenge than when we ran kind of the older generation of batteries, which were only kind of 4 cell and only kind of 16 volts. The voltage spikes that you get here, it's quite easy for it to damage the electronics if you let them get out of hand.
So what do you do to stop that?
So we use kind of capacitors on them, so kind of really low internal resistance capacitors to kind of filter out the voltage spikes. So you put them as close to the source of the noise as possible, which is the motors and kind of the electronic speed controllers.
Yep.
And then that hopefully does it. But you have to kind of make sure they're in good condition and use like the best quality possible.
I can't really get my head round how that's going to make such a difference.
Some of the parts, I guess, is the way to think of it. Kind of the capacitors, things like that, the motor choice, the propeller choice, things like that.
Yeah.
But I gotta go race now, so why don't you grab a set of FPV goggles and then see how we do it.
So, yes, I like that. I can wear my glasses on this. I see Brett has just come out to put his drone on, so I'm putting my goggles on to see if I can join in his race and actually watch what he's doing. And there's a heads-up display in front of all the from what the camera is. So the maximum current is 3 amps, minimum battery 25.22 volts, peak FFT, not sure, total arm 0.02. So these stats are being... Oh, we're off. Oh, my goodness, I've just missed a... ow. Okay, this is very, very fast. We're off, and I'm up and over and round and down and through. I've got through that gate. This is really weird. I feel a bit sick. I'm coming through, round, over that. This is so disconcertingly weird, but also fun in a very mad way. So it does feel like I'm inside a computer game. Over the hoop, under the hoop, round the hoop, back, heading back. It is surreal. Oh. Now that I've watched this 3 times, I'm sort of getting the feel for it. But you can see, though, that this is real muscle memory. You cannot react this quickly. You must just have to know it's going to be left, it's going to be right, it's going to be up, it's going to be down. It is amazingly quick. These things are going so fast. The acceleration is amazing. The power and the control that's in these to be able to do that. They're doing 180-degree turns. It's blown my mind because that was really intense, just being there in the moment and very much in the moment, and probably quicker than any moments I've ever been in before. It was faster than a moment. It was a whiz. So taking my goggles off and actually looking back at the course, I think I now know how everyday tech is giving them the engineering edge. I'm outside the traders area and I've had a good look around at all the shops and the ice cream van. And I've been thinking about what Brett said and what the other pilots were talking about. And yes, to be world-class level, it's at least 80% pilot skill. You've got to have those skills. You've got to have that muscle memory. You've got to know what you're doing. But at this level, milliseconds count. And that's where the technology is really important. And this is why they're putting bigger batteries on, higher voltages. They need more power. Those sharp turns must be causing huge spikes in their power requirements. And if there's a power spike in your camera and your camera goes out, it's game over. If your speed controller goes out, it's game over. If your motors go out, it's game over. It could even cause your electronics to catch fire, and that's a definite game over. And all those hundreds of hours you've spent practicing, those hundreds of hours that you've spent refining your drone just goes for nothing. And this is where a humble capacitor, you can buy it for £1 in RS Components. It sort of acts like a sponge, and it takes when there's too much power, it takes it in, and when there's not enough, you can squeeze it to get a little bit more out. This means that they can push their components to the edge of their tolerance, and by doing that, that can easily give them a few milliseconds of advantage. What I've seen today reminds me of what I saw in Robot Wars, where ostensibly you're competing and you're fighting each other, but actually in the pits, there's just great community. People are helping each other. This isn't some gang warfare, we will fight you till the very bitter end. It's, I want your machine to be as good as it can possibly get, so that when I do beat you, I know that I have beaten your best. So thanks to Brett, to all the competitors and helpers at the drone racing today, I now understand how tech is giving them the engineering edge. I'm just going to go via the ice cream van. Bye!
You've been listening to The Engineering Edge with Professor Lucy Rogers, with thanks to Richard Rowland, Ben Blackburn, Brett Collis and the British Drone Racing Association. The producer and series editor was Dan Page, and it was a Why Did the Chicken production for DesignSpark. If you enjoyed the show, then please do 3 nice things for us. Subscribe, rate us on iTunes, and tell a friend how disappointed you'll be in them if they don't try this amazing new podcast you found. For more episodes and bonus content, head to designspark.com/podcasts.
Ice creams.